So let's lay the foundations, lay a little groundwork for why we really need to use agile and adaptive approaches in many of our modern projects. In our modern projects today, there's a lot more volatility with requirements. And the reason for that, in our modern world, there's a heightened level of competition due to globalization, due to the internet, the ability for teams to work virtually. They can put together things very fast, and there's a lot more volatility in the requirements. Things are changing so fast, it makes your head spin. As a famous author, Thomas Friedman, says in his most recent book, Thank You for Being Late, he said, we're in an age of accelerations. And in this age of accelerations, again, there's a premium on creativity, on discovery, on exploring requirements. So to lay the groundwork for that, let's compare Agile to how we used to do things in software with waterfall. So software projects typically do have quite a bit of volatility. And back in the day, several decades ago, this is how we did things. We approached things in a waterfall type fashion. And I should know this well because this is what I did to support the family back in the late 70s as a systems analyst designing database applications and such. So we might go through a conceptual design phase where we're going out and getting all the user requirements and building a functional specification. And we might spend a month or 2 or 3 months doing that conceptual design, building that functional specification. So we create that document or documents, we get the reviews, we get the approvals, we tie a bow around the functional specification, and we hand that off to the systems analyst doing the detailed design. And they put together the file layouts, they break down the application hierarchically, for the application down to programs, programs down to modules, modules down to subroutines, subroutines down to functions. They lay out what the parameters are that will be passed from subroutine to subroutine, what the interface is going to be. So they're putting together a system architecture document or subsystem spec, and we might have spent months and months doing the detailed design. So we take that detailed design, that system architecture document, we hand that off to the programmers, the COBOL programmers doing the writing of the code. And how long did that take typically to get done? Circa 1979, 1980. Oh, that could take more than a year. That could take a year and a half to write the code for a typical database application of 100,000 lines of code, 150,000 lines of code. It might take a year. So they get that all through unit testing, get it into integrated testing, have it pass integrated testing, and then finally, that glorious day happens. We need to bring in the customer now to check everything out. We're at what? We're at UAT, user acceptance testing. And how did user acceptance testing go? Oh, that didn't go very well in many, many cases. Why not? Well, how long was it before the customer got to see this running application? How long was it from the time where we went out and got all the user requirements to the time where they can really kick the tires, test out the application, see what response times are, see what throughput times are, and really test everything out? Oh, that's more than a year. That's a year and a half, maybe 2 years before they get to really try out the application and see how it really works. And again, that's 2 years. What's happened in those 2 years or that year and a half? The world has changed. And they want all this change. The new technologies, new ways of indexing databases to provide faster response times, better GUIs, graphical user interfaces for designing screens, for displaying data, for inputting data. They want these better GUIs. So they're not happy with this design that was created 2 years ago, a year and a half ago. It's also another thing. It's not until they really see it and test it and touch it and play with it that they realize what they needed in the first place. So UAT typically did not go very well using a predictive waterfall life cycle. In some standard surveys that have been done every few years over the past couple of decades, they came out with very alarming survey statistics saying less than 30–40% of all software projects done with a predictive lifecycle approach, less than 30% of those are successful, meet the triple constraints, meet the schedule, meet the budget, meet what was called for with scope and quality. So we're going to do things differently with adaptive life cycles or Agile. We're going to divide the project up into short iterations. So each of these iterations or sprints are typically between 2 and 4 weeks. And in each iteration, we're going to create some product increment or deliverables, something to display, something to show the customer at the end of the iteration in a review meeting. So they get to check out that deliverable, that product increment, and kick the tires and find out, does it meet their needs? Does it meet the business value that they were expecting? So we're identifying fast failures. Very, very quickly, we're getting something out empirical to let them test to find, does this have value? And there's much more frequent interaction. We're not waiting 2 years, a year and a half to deliver an application to the customer. No, every 2 weeks, or perhaps at the far end, every month, we're giving something to the customer for them to empirically check out.